Hello everyone, hope you all are doing well. So in the last topic we have read about efficient potassium use, that is topic 29. Today in the topic 30 we are going to do efficient phosphorus use. So first of all we should know what is phosphate fixation. First of all, biological fixation. Biological, actually you should all know that biological fixation happens in all soils during decay of organic residue. In all soils during decay of organic residues. The second is chemical fixation. So chemical contains of two types. First one is option, that is by Fe and Al, iron and aluminum oxides, and clay minerals. It is greatest in acidic soils, but to some extent it is present in all soil. Greatest in acidic, but to some extent in little amount or in medium amount it is present in all soils. And in chemical, the second one is precipitation. B, that is precipitation. Here, insoluble ferrous aluminum phosphate in acidic soils. In precipitation we have insoluble FeAl phosphates in acid soil as partially available calcium phosphates. As this is B point. Partially available calcium phosphates in near acid to neutral soils. Number C is formation of highly insoluble carbonated hydroxyapatite in calcareous and alkaline soil. So we have got it for precipitation: insoluble Fe and Al in acid soil, and Ca calcium phosphate in near acid soils, and formation of highly insoluble carbonated hydroxy in calcareous in alkaline soil. So this is what phosphate fixation. But what kind of reactions do take place during phosphate reactions? The phosphate is fixed by following reactions. The phosphate is fixed by following reactions. Number one is adsorption. I hope you all have read it in class 11, 12th in chemistry. Adsorption also consists of two types. First one is physical. So phosphorus held on soil. Here, as you know, in adsorption, the soil surfaces held some phosphorus. So in physical, phosphorus held on soil solid surface, and during chemical adsorption, retained phosphorus penetrate more or less uniformly into solid phases. Adsorption also happens on surface of constant charge. Adsorption happens on surface of constant charge, it is clay minerals. And when it happens on constant of happens on variable charge, on surface of variable charge, it is Fe and Al oxides. And organic matter. And you should also know that in high temperature, the degree of adsorption is also high. Adsorption is also high in high temperature. So this was the first one, that is adsorption. The second one is isomorphous replacement reaction. Isomorphous replacement reaction, that is IRR. It is regarded as adsorption plus. Adsorption plus. This is a greater version of adsorption, you can say. That is why adsorption plus. Phosphorus fixed by hydroxyl OH minus and silica ions through isomorphous replacement reaction. Here also the reactions of Fe and Al with phosphorus are more efficient. Reactions of Fe and Al hydroxides with phosphorus are more efficient as compared to adsorption. The next point, the next method is double decomposition reaction. Double decomposition reaction. It is based on solubility product principle. Based on it highly depends on pH. That is high pH, which means low phosphorus fixation. Higher the pH, lower the phosphorus fixation, and organic matter decreases phosphorus fixation in most of soils. Decreases phosphorus fixation in most soils. Soils with high organic matter, so less phosphorus fixation. So this was all about phosphorus fixation or phosphate fixation. Now moving on to next topic, that is factors affecting phosphate fixation. What are the factors affecting phosphate fixation? The first factor is nature and amount of soil components. Soil components, here hydrous oxide of Al and Fe. When they are less, when hydrous oxide of Fa, aluminum and iron are less, then phosphorus fixation capacity is more because of greater surface area. Hydrogen Al is less, therefore phosphorus fixation is more. Why? Due to greater surface area. Type of clay. Phosphate is fixed at greater extent, in higher extent in 1:1 type than 2:1 type clay. It is completely opposite of potassium. Potassium was high in 2:1 and low in 1:1, but in phosphate it is high in 1:1 in low and low in 2:1. Number C is amount of clay. More is the clay, more is the fixation. Moving on to the next point, that is amorphous colloids. Like allophane have a large negative charge which is balanced by complex aluminum cations. Phosphorus becomes absorbed by reacting with these aluminum. And what happens in amorphous colloid like allophane? Have large negative charge which is balanced by complex aluminum cations. Phosphorus becomes absorbed by reacting with these aluminums. By reacting with these aluminums. So what happens in amorphous colloids? That's the negative charge of the aluminum cation gives more space to phosphorus to react. Hence, higher the amorphous colloids, high will be the fixation of phosphorus. So the next point is calcium carbonate. That is CaCO3. Here also, due to the presence of calcium carbonate, it will absorb more phosphorus. So higher the amount of CaCO3, higher will be the fixation. Now moving on to second point, that is pH. So in pH there is no fixed amount how phosphorus will be absorbed or fixed. The lower the pH, the lower will be the fixation, and higher the pH, higher will be the fixation. So it doesn't differently depends on pH. So next point is organic matter. The soluble phosphorus. The next topic, in previous topic I have also said you that because of presence of high organic matter, the concentration of phosphates become low. That results in low fixation. So here in organic matter, the soluble phosphorus will have lower fixation. Then temperature. As we all know that temperature always act as a reagent of fixation. So higher the temperature, higher will be the fixation. I hope all of you have understood the factors affecting fixation. Next point is overliming. As we all know that liming helps us to reduce acidity of the soil. So what happens due to the presence of or using high lime, the amount of fixation of phosphorus will be increased. As we all know, in high acidic soils the phosphorus fixation is always low. So when we do overliming, it will reduce the acidity and hence increase the fixation of phosphorus. Use of ions also, you can see cations always enhances phosphorus fixation. In the previous points we discussed about aluminum cations, that they are very good for phosphorus fixation. Anions do just opposite of cations. Cations enhances, so anions will always reduce, because anions will not give you that much space as the cations give for the fixation. Now moving on to the next topic, that is Forms of phosphate. How many types of phosphate are present in our soil? This question has been asked in previous years, so it is important. Do make notes. I always say you in every lecture that the notes you are going to make is your Brahmastra. You are going to get maximum of the question directly from your notes, as in agricultural optional we all know that previous year questions are repeated. So in organic group we have got four main types. So first one is with aluminium, that is aluminium and phosphorus chain, that is aluminium phosphate you can also say. Second one is with iron. Third one is with calcium, and the fourth one is with Fe and Al both. So what will happen in fourth one? As you see in the first and second one, Al and Fe act in different circumstances, but in fourth one you will see that these two will be in the same chain with the phosphorus. So this was the inorganic presence of phosphorus. Now moving on to the organic presence. So in organic phosphorus, they always occur with esters of orthophosphoric acid. Esters of orthophosphoric acid, and we all know that esters are divided into 5 classes for phosphorus in soil. So the first one is in silyl phosphate, second one is phospholipids. We all know these are the types of esters, so we will just add phosphorus to it. Nucleic acid, the nucleic acid of phosphorus. Then we know about nucleotide, and lastly we will have sugar phosphates. I hope you all have read about DNA somewhere, or we will study in the physiology part. So DNA contains nucleic acid, nucleotide and sugar, these things. So here the same thing is happening, but here we will have with phosphorus, and not in our DNA but in soil. So nucleic acid is present, soil phosphate is present, nucleotides is present, phospholipids are present. So this was about organic phosphates. So you all know that in Indian soils we have got high amount of potassium, but when it comes to phosphorus it is in lower amount. That's why when you apply fertilizers, most of times we apply 3:2:1, the higher amount of nitrogen, because it is highly taken up by plants for their growth. But when you see potassium and phosphorus, potassium is given in 1 ratio while phosphorus is in double ratio of potassium. Why? Because Indian soils are rich in potassium as compared to phosphorus, while phosphorus is low in amount in Indian soil. So what could be the reason behind it? So this was also asked in previous years, so it also becomes very important for us. So reason 4, low availability of phosphorus. Because first point you can write as soluble phosphorus react with clay, iron and aluminum compounds. So what it does, that due to the reaction it changes itself into non-mobile forms, or not in forms that are readily available to plants, or not in forms that are readily available for fixation. We all know that insoluble phosphorus is good for fixation, while soluble phosphorus is always slow in fixation. So this is the first reason. So second is the mobility. Phosphorus moves very little in most soils. The movement of phosphorus, we all know that nitrogen has a very high mobility, but when it comes to phosphorus and potassium, they are little less mobile compounds. So I have already taught you in fertilizer application that when we add phosphorus, we always try to keep it near the root so that it can be easily absorbed by the root. so it is less mobile as compared to nitrogen. So in most of the soils it is less mobile, and so crops are not able to absorb the remaining amounts also. First of all, phosphorus is in low amount, and the amount which is present also are not available to crops because of its low mobility. Third point you can write, that's erosion, soil erosion. So what happens due to erosion? Phosphorus gets highly eroded by the soil because it always remains in the upper layers of soil. So when the soil is eroded, the phosphorus in the upper layers get highly eroded with the soil. So whenever you see fields with high irrigation or flow irrigation, surface runoff irrigation types, you will always observe that the phosphorus quantity of that fields are always low, because due to erosion the phosphorus of upper layers, most of the phosphorus remains in upper layers in our agriculture field are washed away. pH also is another factor. So most of the soils, especially in the northern belt like in states of Jharkhand, Bihar, are acidic in nature. You will always observe that these soils, and also northeast region where we have got high rainfall, so these soils are acidic in nature. And we all know that in acidic soils the fixation of phosphorus is always low. We have seen this in the previous topic also when I was discussing factors. So for that, we know I have discussed about overliming. For that you need to do lime application, but as India has more acidic soils as compared to basic soils, so the phosphorus content is always low due to less fixation. So the pH of 6 to 8 is best for phosphorus presence, and for fixation soil must be basic. The next point is low soil temperature and poor soil aeration. What we tend to do during cropping, that in India you will observe that we use high amount of irrigation in crops, more than the required amount. We never do irrigation scheduling. So what high amount of irrigation does, it decreases the soil temperature, and also it affects the aeration. As the upper layer is over flooded, the air is not able to pass to the lower levels. So due to this poor soil aeration and low soil temperature, the amount of phosphorus availability becomes low. Next point is organic matter and microbial activity. P in organic form can be mineralized and immobilized. So phosphorus in inorganic forms is mineralized and immobilized. So what it does, due to immobilization of phosphorus, it is not that much availability of P in soil, and hence our crops are not able to get those phosphorus. So what are the agronomic measures to increase phosphorus use efficiency? Agronomic measures to increase phosphorus use efficiency. First one is addition of organic matter. What it does, it contracts CaCO3, reduces P sorption, reduces sorption of phosphorus, and increases P concentration from mineralization. Second, placement of fertilizer. As I have talked earlier also, we need to place the fertilizer near root zone of plants, as phosphorus is immobile. Use of mycorrhiza. helps the plants to absorb more P. What it does, it helps plants to absorb more phosphorus. Hope you are understanding it. Fourth is use of phosphorus soluble microorganism. Example, Bacillus megatherium. So what it does, it enhances the ability of availability of fixed P, enhances availability of fixed phosphorus. Liming of acid soils, it releases fixed phosphorus held by Fe and aluminum. You can use bone meal, rock phosphate. So these things also helps in phosphorus availability. We need to do crop rotations. We need to use crops with higher root expansion so they can absorb the immobile forms of phosphorus also. So that was all for today. I hope you have all understood it. If you like the video, please press the like button. For any queries, do comment and do share and subscribe. That's all for today. Have a nice day. Thank you.